today we are solving linear programming problems. I'm giggling for those at home because we've already started this and I forgot to hit record. So, linear programming problems are used a lot of times in business to maximize and minimize profit. So here's our first problem that we have copied down. The very first thing we do is we graph our constraint function. So let's see what that looks like. Here they are. We're going to shade right here. After we graph our constraint function and shade in the correct spot, we then need to use our solving systems by graphing and figure out the points that make this shaded region up. And Sydney, can you tell me the first point? 2, 0. Wonderful. Pass it off. Lovely. Pick somebody. Lovely. Pick somebody.
5, 3.
Not quite. 5, 2. 5, 2. So this is very important that we actually make sure our lines are carefully placed, because 5, 3 would have messed my entire part up. Okay. So now that I have my points, I'm actually trying to maximize and minimize this function they gave me. They have to give me that function in some way. So I'm going to plug the 2 in for x and the 0 in for y. I'm going to do them right beside the point. So negative 2 plus 3 times 0. And if I do that math, I get negative 2. Go ahead and figure out the other 3 values. All right. Sammy, can you pick one of those 3 points, tell me what the answer is. 4, 5, 0. Okay. Lovely. Pick somebody. Oh, it's not 2, 0. It's 2, 8. Perfect. Go ahead and pass it off. Perfect. All right. So far, any difficulties? Okay, so now all you have to do is write your answer because you've done all the work. Okay, and here's how we write our answer. We say min of, what's our minimum number we came up with here? Negative 5. So min of negative 5 at, what point made that? 5, 0. And that's my minimum value. Go ahead and write your max now. Of 22 at 2, 8. Any questions? Okay, now, I can tell you right now, if I pick any point inside this shaded region, because the shaded region is all closed off, isn't it? It's kind of like a horse pasture or pig pasture or something like that, where they can't get out, right? If I pick any point inside here and plug it into that C function, that number will be between negative 5 and 22. So it will not be the min, it will not be the max, it will always be between those two. But I wonder what happens if it just goes on and on forever. So let's do one more. Last one of the day. Go ahead and copy this one down. Oops. There we go. And go ahead and graph your 3 constraint functions. So I'm going to go ahead and solve this bottom equation for y. And what I do is I subtract x from both sides. But I don't ever like my y to be on the right side. I always like it to be on the left side. So I'm going to reverse it. When I reverse it, I have to flip the sign also. And I'll write the negative x plus 5. And that way when I graph it, it's a little easier. I went ahead and I already did the graph. So here it is. Please note it's shaded in here. Now, Here's something a lot of students do. They graph the lines and they don't put the arrows on. Instead they say, hey look, it made a triangle, I'll shade there. I didn't put the arrows on.
Yeah, me too.
Be careful because your arrows are both going which way? Down, right? Yeah, that's going to be shading in here. Okay. Now, what I want you to do is figure out what points make up this shaded region. How many points make it up? I see 2. No, there's a ton of points down in here, but 2 make up the lines that I can see, right? See if you can figure out what those 2 points are at this time. All right. What 2 points do I have? Noah. 0, 2. Noah, pick somebody. Hey, what's the other point? 1, 4 is good. So, at this time, plug both points into your C function. Haley, what'd you get for 0, 2? 10. Pick somebody who hasn't talked yet. 1, 4. 21. Now, Jake actually asked a very good question. He said, well, since I only got 2 numbers, wouldn't that be my min and my max? But notice, this goes on and on forever down here, doesn't it?
Yeah.
So on the other one, I told you because it was bounded, if I pick a point in the pink, then it would be between that min and max. But is this one bounded?
No.
No. So let's pick a ridiculous point in the pink region here. How about 10, comma, negative 500? 10, negative 500, something ridiculous, right? Plug in 10, negative 500 into the C function. Like I said, something ridiculous.
10, negative 10 what?
10, negative 500. So, I got negative 2490. Now, could I pick even something more ridiculous than negative 500?
Oh, yeah.
So, it's going to get smaller and smaller each time, right? More and more negative. So, is there a minimum here?
No.
No. So I actually get to write no min because it's unbounded. So when it's unbounded, you've got to pick a point in that pink to figure out is there no min or is there no max. Because it could be that there's no min and there is a max, or it could be there is no max but there's a min. Does that make sense? So you pick a ridiculous number. You check to see is it bigger or smaller than this. But what's my max at then? So I say max of 21 at 1, 4. And that's it. Well, not necessarily. Not necessarily. Is this C function actually? Let me clear that. Is that okay? Clear. Let's say the C function was actually negative x negative 5y. Okay, if I did the negative 10, 10, negative 500, 10, and then negative 500 would actually give me positive, right? Even though it's going down, because that C function changed, there'd be no max. Does that make sense? So you can't go on which way is it graph. You have to pick a point, a ridiculous point, in that pink region, and see which one it is. Does that make sense? Okay. Well, I want to give you 4 problems of homework tonight.
4.
Here's the best part. Are you ready? The first 2 are graphs for you in the book and give you the points. You just have to plug them in. The last 2 you actually have to graph. So you're only graphing 2. So pull out a sheet of graph paper. And here is your 4 problem.